Hi, my name is Dave Spitzfaden, and I'm a data scientist interested in natural language processing and predictive analytics. So for the past 2 weeks, I've been working on a project to predict county health inspection grades using Yelp data. The reason I wanted to do this is a couple reasons. First, I think that it can help health inspectors better utilize resources and have a live indicator of restaurants that could be at risk for health violations. On a more personal level, I like to go out to eat on Friday night, and I don't like to wake up with food poisoning on Saturday. For my project, I use a pretty standard data science tech stack, with the exception of a package from SeatGeek, which helped me do some fuzzy matching on strings. And I did that because the biggest challenge I had was to merge two very distinct data sets. So the process I used to do that is, after trying a lot of different methods, the best method that I found was to strip out anything that wasn't a digit out of the address, merge the two data sets on that unique digit, and then perform a fuzzy ratio score using that package to calculate how similar those strings were. So for an example for that, the first one in the Yelp data set, it labels it as having a suite, whereas in the second one it does not have a suite. So you take that out and they have the same numbers as the address, and then in this case, they also have the same restaurant name, so they have a fuzz score of 100. On the next example, something that has, a pretty similar address, but when you strip it out, it has the exact same, 2544. But in this case, the Yelp data set has it as just sticky rice, whereas in the county health data, they have it as sticky rice Thai restaurant. So that got a fuzz ratio score of 60 based on those two restaurant names. An example where this wouldn't work would be two completely separate businesses that have the same address number but are on different roads. So in this case, 4170 Pioneer Avenue and 4170 South Fort Apache Road would both be merged as the same, but their restaurant names are very different. One is actually a plumbing company, and the other is a pancake house, and that name would get a fuzz ratio score of 30. So using that kind of fuzz ratio score, I made a histogram of where the distribution of those scores, and then figured out where the threshold was working and where it wasn't working. And after looking through a lot of data there, I found the best threshold was around 60. And that, again, was the second example that had a slightly variation and a very similar address. And so what that meant was that when I started with around 30,000 Yelp businesses in Nevada, I was able to match about 2,000 of them using this methodology, which resulted in about 105,000 business reviews, and eventually all of those bundled up into health inspection periods, and I had about 11,000 health inspection periods that I could use to predict. So now that we have two data sets merged into one, we can start making really cool charts using data from both of them. This chart looks pretty simple. It's just the percent that each category of restaurant has a health grade of A, or a health grade of B, or a health grade of C. But actually this is really cool because the county health data actually only has very broad categories like restaurants, grocery store, or school at a very broad level, whereas now we're able to be more granular and say a Vietnamese restaurant has a 60% chance of getting an A, whereas a Mexican restaurant on average has way more grade A's. And then the other thing I want to point out on this chart is that overall the grade A is by far like the most popular health inspection grade. So I have a pretty imbalanced data set. And one way that I'm going to account for that in my final model is to only predict A or not A. So we can also start to look at really cool things based on the Yelp distribution stars by health inspection grade. So to do that, I performed a chi-squared analysis for restaurants that had a health inspection grade of A and all the other combinations. And what that chi-squared test does is basically test if the distributions are the same for two different populations. And it assumes that the distributions are the same. So if you have a low p-value, that's the probability that you would see that given result or more extreme results. So a low p-value would mean that we can assume that, or we can reject that they are the same. Whereas a high p-value for A versus B and B versus C, you can't assume that those are unlikely. So here this graph is showing that A and C have very different Yelp star reviews, but A versus B and B versus C both look pretty similar. And that's like pretty cool if you think about it. And what I was able to do after that is run some NLP on the actual text data of the reviews, and run a random forest to try and predict what the actual health inspection score is. And when I did that, I was able to get a precision of 0.81 and a recall of 0.83. And I want to give you guys an example of kind of why this model was performing the way it was. So I pulled out some examples that were correctly predicted as C's. And you can see words like rubbery and chewy, almost gristly, are being pulled out, in addition to things like I became sick from this. But also because the distributions of B and C are still kind of similar, you can also still see things in there like consistently delicious and the sauce is yummy. So this is all to say that while you can tell a little bit of a difference, the health inspection scores are pretty similar. So my next steps for this project are to better refine my model to get better results, and instead of predicting A or not A, try to get down to that A, B, or C level. And ultimately, I would like to build a web app that you can put in like the URL of a Yelp restaurant page, and it'll try and predict what the health inspection grade is. So if you want to follow my progress or have any questions, feel free to reach out. My email and GitHub and LinkedIn are all on the screen.